morning, you meet Mrs. Janet Sintima Boaje, a lecturer at Christian Service University College. My topic is maturation of the ovum and the sperm. Maturation of the ovum and the sperm. Before ovulation, certain changes take place in the ovum. These changes are collectively described as the maturation of the ovum, and they must take place before ovulation. During the maturation, the ovum cell divides and is known as mitosis. After the cell division, there are two resultant cells, chromosomes. They are thread-like structures in the nucleus of the ovum and sperms. Each reproductive cell, that is ovum and spermatozoa, has got 46 chromosomes. 44 of these chromosomes are for character determination or somatic cells, and the two are for sex determination or somatic cells. In the ovum, that is female, the sex-determinant chromosomes is designated as XX. In the spermatosome, male, the two sex-determined chromosomes are called XY. During the cell division in the ovum, before ovulation, the two resultant cells that are produced contains 23 chromosomes each. One of the resultant cells is bigger than the other, although they both contain 23 chromosomes. The smaller resultant cell is called the first polar body, which is casted away and absorbed for excretion. The bigger resultant cell still bears the name ovum, and it is that one that is produced at ovulation, which carries 23 chromosomes, 22 character determinants, and X sex chromosomes. The bigger resultant cell still bears the name ovum, and it is that one that is produced at ovulation, which carries 23 chromosomes, 22 character determinants, and X sex chromosomes. Maturation of the sperm. The spermatozoa is the male reproductive cell. It has a tiny structure. It has a head, neck, and tail. It moves along the genital tract by the movement of its tail. The head of the spermatozoa contains the nucleus, and inside are 46 chromosomes, 44 character determinants. The head of the spermatozoa contains the nucleus, and inside are 46 chromosomes, 44 character determinants that is the X and Y in the male before the spermatozoa are released for fertilization. They also undergo a maturation process where the male reproductive cell is divided into two. Each has 23 chromosomes. Determination of the sex of the fertilized ovum. Ovum. During coitus, matured spermatozoon carrying 23 chromosomes each are deposited in the birth canal. By chemical attraction, they travel in that direction. The first to reach the ovum penetrates it and fuses with it, and fertilization takes place. If the sperm that is carrying the S chromosomes fuses with the ovum, then the zygote will be female. If the sperm that carries the Y chromosomes unite with the ovum, then a male is obtained. Fertilization. This is the union of an ovum and sperm occurring usually at the ampulla of the tube 24 to 48 hours after ovulation. About 300 million sperm are deposited in the vagina during coitus, but only one fertilizes the ovum. Many of the sperms are killed by the lactic acid in the vagina. The first and strong sperm to meet the ovum fertilized it. They survive for about 48 to 72 hours. Once one sperm reaches the inside of ovum, no more sperm can penetrate. The sperm that enters loses its tail and gets into the inner layer of ovum. The head of the sperm meets the nucleus of the ovum and it loses its membrane so that the two joins. Their chromosomes combined to give the number 46. Fertilization usually takes place in the fallopian tube at the ampulla. It is the largest cell, the ovum. It is the largest cell in the body, which is about 0.15 millimeters in size and visible to the naked eye. It has a double layer of cell wall. The inner layer is solid and the outer layer is made up of hundreds of smaller cells. The nucleus contains 22 somatic cells and a sex cell, which is always XX. The ovum cannot move by itself, but by the help of the cilia in the fallopian tube. Every month, the average woman releases an ovum after ovulation, which passes through the fallopian tube by the action of ciliated epithelium and peristaltic movement of the muscular layer onto the uterus. It takes about 5 to 7 days to reach the uterus after ovulation. The ovum is able to be fertilized within 24 to 36 hours. The sperm and ovum have 2 X chromosomes each. After fertilization, the fertilized ovum will have 46 chromosomes, that is 23 plus 23. In the female, the sex chromosomes are alike, that is XX. In the male, they differ, that is XY. The sex of the fetus is determined at fertilization by the sex chromosomes from the sperm. After coitus, many of the cells are killed or destroyed by the lactic acid of the vagina. Those who are able to escape and thrive through the alkaline secretion in the cervical os may travel through the uterus to the fallopian tube to fertilize the ovum, usually at the ampulla. After fertilization, no more sperm can enter. During coitus, 300 million to 400 million sperms are deposited in the vagina, but one is needed for fertilization. The sperm may survive for about 48 hours when the sperm enters the ovum. It loses the tail and penetrates the inner layer of the ovum. The head meets the nucleus of the ovum so that the two join. Development of the fertilized ovum. After fertilization, the fertilized ovum or the zygote is propelled along the fallopian tube into the uterine cavity by the aid of cilia and the action of the muscle wall of the tube. The journey from the fallopian tube into the uterus takes 3 to 4 days and about 6 days after ovulation. The cells undergoes rapid cell division into 2, 4, 6, 8 until a mass of cell is formed called morula. A cavity with fluid appears in the morula and the cells are pushed to one side, which is called the inner cell mass or embryoblast, and this will eventually becomes the fetus. The outer cell mass is called trophoblast, and this becomes the placenta or afterbirth. The space between the inner cell mass and the trophoblast is the blastocell. The whole mass is called the blastocyst. Formation of the decidua. When the blastocyst has reached the uterine cavity, the decidua is formed and the ovum embeds in it. The two events occur simultaneously. The decidua is formed due to increased secretion of progesterone. The corpus luteum does not degenerate on the 28th day of the menstrual cycle when fertilization occurs. Instead, it grows bigger, thicker, and occupies about a third of the surface of the ovary. It continues to produce progesterone in large amounts and a little estrogen until 12 weeks of pregnancy, when the size of the corpus luteum decreases. The formation of the enlargement of the corpus luteum is due to the chorionic gonadotrophic hormone secreted by the cells of the trophoblast. This hormone is referred to as the anterior pituitary lobe principle. That is, anterior pituitary hormone. During this time, the endometrium grows more to a depth of about 8 millimeters with the layers well developed. The stroma cells become increasing by vascular, and the compact layer is closely packed together with the glands of the spongy layer becoming more tortuous and distended with secretion. The basal layer becomes unchanged. Embedment of the fertilized ovum. About 6 days after ovulation and 4 days after fertilization, the ovum enters the uterine cavity on the decidua. To begin the process of implantation or nidation. Implantation coincides with the period when the endometrium is most prepared for the fertilized ovum. The cells of the trophoblast secrete some digestive enzymes which digest the cells of the decidua. A depression is formed in which the blastocyst now rests. The process of the digestion continues until it is large enough to accommodate the blastocyst, and this takes place about 14 days after ovulation. The implantation occurs about 28 days of the menstrual cycle, when the woman will be expecting her period. Slight bleeding may occur as the trophoblast cells eat through the blood vessels during implantation, and this may be mistaken for scanty menstrual flow. As the epithelial lining reports its cells to enclose the blastocyst, the blood of the eroded vessel begins to supply the blastocyst with nourishment and oxygen. At this stage, 3 names are applied to the decidua, known as decidua basalis, decidua capsularis, decidua vera, or true decidua. The decidua basalis. The part lying beneath the blastocyst, or the part where the blastocyst rests, is known as the basalis. Decidua capsularis, part that covers the blastocyst directly or lies over the developing ovum. The decidua vera, or true decidua, lines the remainder of the uterus. The ovum usually embeds in the decidual lining of the fundus of the uterus, in the upper part of the anterior or posterior part of the uterus. With continuous growth, the uterus enlarges quickly, and by the 12th week, the decidua capsularis meets with the decidua vera. The decidua capsularis degenerates or disappear. layers of decidua: compact layer, spongy layer, perforation layer, basal layer. Development of the embryo. During the 3rd week after fertilization, cell differentiation begins within the inner cell mass, and this develops into specific body system called embryonic area or plate. 2 cavities are found: amniotic cavity and yolk cavity. The layer close to the amniotic sac or the lining of the amniotic cavity is called ectodermal cells or inner layer, and this forms the nervous system, skin, mucous lining, nails, hairs, enamel of the teeth, and the eyes. Development of the embryo continues. Middle layer of mesoderm is found between the ectoderm and endoderm. It forms the circulatory system, muscles, bones, kidneys, and blood vessels. Outer layer or endoderm. It lies closely to the yolk sac, and it forms the digestive tract and some internal organs like liver, spleen, pancreas, bladder, and thyroid gland. The 2 cavities which appears within the inner cell mass are the amniotic sac and the yolk sac. The yolk sac. This provides nourishment for the developing embryo until the trophoblast cells develops to absorb nutrients from the maternal tissues, and then it atrophies. The amniotic sac. This is filled with fluid called the amniotic fluid with rapid growth. The amniotic sac surrounds the embryo and protects it till term. The embryonic plate. This grows with the enlargement of the amnion and forms the embryo. The ectodermal, endodermal, and mesodermal cells develops to form the respiratory organs of the fetus. The body stalk. It is a mass of cells by which the trophoblasts become attached to the inner cell mass. Later on, it becomes the umbilical cord or funis, and it allows the fetus to be mobile in the amniotic fluid. The blood vessels and the body stalk becomes the umbilical vein and the umbilical arteries. The cells of the body stalk and amnion fuse together and become continuous with each other. Development of the placenta. During the 3rd week, the ovum is completely covered with chorionic villi and are known as the primitive chorionic villi. The villi in the region of the decidua basalis multiply rapidly and are known as chorion frondosum, which forms the placenta. The villi in the region of the decidua capsularis becomes thinner and smaller as the blastocyst stretches, and they degenerate, leaving bulb or chorion naive. The cells of the trophoblast continues to secrete enzymes to digest the decidua and blood vessels, so that there is bleeding from the chorion decidua space form where the blastocyst absorbs its nourishment and oxygen. The space between the villi are called blood spaces, and the open vessels are called sinuses. At this stage, a new system of blood vessel is formed in the core of the villi. Vessels from each branch of the villi unite at the base to form a big vessel. Then vessels from each villous stem also unite to form large blood vessels, which run through the umbilical cord. A villus. Each villus has 3 layers. They are syncytiotrophoblasts or syncytium. The outer layer, which has a layer of protoplasm with nucleus scattered in it, and it grows rapidly. Cytotrophoblast or Langerhans layer. The inner layer lies beneath the syncytium. Mesoderm or primitive mesenchyme layer of loose connective tissue which is continuous with the inner cell mass. The center of the vellus is the mesoderm and blood vessels, and these develops to form the fetal blood vessels, which are 2 arteries, 1 vein. The cells of the villi has the power to select and absorb nutrients from the maternal blood to the developing embryo. Waste products from the embryo is also excreted from the fetal blood to the maternal blood. The fetal and maternal blood do not mix because the walls of the villi lies between them. Some of the chorionic villi enter deeply into the decidua and are referred to as anchoring villi. Anchoring villi. They are long and are attached to the deeper layer of the decidua, and they fix to the placenta to one side or place. Under normal circumstances, the anchoring villi do not penetrate into the basal layer of the decidua because of a fibrous material which form beneath the spongy layer and are known as the perforation layer or layer of Nitterbusch. Thank you very much.